Hi, my name's Corey, and this is the first video in our series on from scratch. In this first series, we're going to be building a web framework from scratch. We'll be building it in PHP. This is kind of inspired by Gary Bernhardt's Destroy All Software talks, but it's going to be a little bit different. We're going to build a pretty full-featured web development framework. We're going to be building it from scratch. I'll be coding it in the editor, and then I'll be doing a follow-up video after each one of those where I kind of go into more detail about each of the issues. You don't have to watch me actually type everything out. So hopefully you kind of get the best of both sides. You can kind of see how we're designing the software, what the thought process is as we're making their programming decisions, and then also after the fact, just get right to the point. What does it do? How does it do it? So in this web design framework, I hope you're going to learn something new, especially if you're a PHP programmer. We're going to be taking some more, I don't want to say advanced, but say more Java or C#.NET kind of design features, and we're going to implement those. So we have a few design principles for our web development framework. One, adding new pages should be simple. We're going to have a one-to-one mapping between our program code and our web URLs, okay? We're going to be using inversion of control. That means it's going to be very declarative. So rather than using an imperative style of programming where we say, first do this, then render the header, then we're not going to do that. What we're going to do is we're going to describe how our page should function, and we're going to let the web programming framework call into our application. So our application will be providing services and features, and then the web application framework is actually going to call into us and use those features to render the web page. So it's going to be a little bit different than what you might be used to, and we'll get into some of the reasons why we do that, most notably testing, and then also just code reuse. All pages should be unit testable, so this goes with the inversion of control principle we were just talking about. Because we're using it, we're going to build our own inversion of control system. That's going to make our code much more testable because we're going to allow the test to define all the dependencies for the test environment, and we're going to allow the web framework to define all the dependencies for the web framework, and we're going to run the exact same code in both environments. And lastly, it should be highly performant. I'm really looking for sub 3 millisecond page renders for dynamic content. If we need to make a database connection, that's going to get a little bit slower, but I think we should be able to still get single-digit page render times even with pulling data back from MySQL. We may have to do a couple of hacks to get it quite that fast, but I think it's possible, especially since we're going to be designing the entire framework in PHP 7.3. When I'm recording this, it's 2019. PHP 7.4 is just about to come out. PHP has a ton of issues. We're going to talk about those. Inconsistency, there's a bunch of issues that drive people nuts when running PHP, but it is 80%, maybe not quite 80%, but certainly over 50% of the internet runs on PHP, and a lot of small medium businesses run on PHP. If you're doing anything on the web, it's kind of nice to know. So let's talk about some of the features we're going to build. We're going to build a request router that's going to route our URLs directly to our code. We're going to have an inversion of control container that basically each piece of our code is going to define what its dependencies are, what it needs, and the inversion of control container is going to dynamically set that for us. We're going to talk about how to do that really, really fast. We're going to have authorization and authentication. Those things are going to be provided with PHP code annotations. So we're not going to actually write any code in our application to do authorization or authentication. We're just going to define what authorization we want, what authentication mechanisms we want. We're going to build a parser that handles those annotations. That's going to tie into our IOC container. We're going to have local caching. So we'll be using, I may go so far as to build our own malloc implementation using like the shared memory op extension or the system V memory extension where we just have a big flat piece of shared memory and we just allocate it and hack it up ourselves. I may do that. It's actually can be faster than running code like APC or APCU. When we get into that, we might take a quick look at that. We'll define some hash mapping algorithms, do some other fun stuff. We're going to build a database layer. We're going to abstract ourselves away from MySQL. We're going to be MySQL specific. We could make something a little more generic that talks to Postgres or Microsoft SQL Server, but honestly, MySQL is 80% of all PHP installations, so we're going to keep it with MySQL. There are some caveats. There's some really important things to note when using MySQL. It does some things that you might not expect it to do. For instance, UTF-8 isn't actually UTF-8, it's MySQL UTF-8. And has some other really interesting functionalities when doing string to integer comparisons and other things. We're going to talk about that. Views. We're not going to be using Smarty or anything like that. We'll be building our own view templating library that's made on XHTML. Has some advantages and disadvantages. Sometimes it's nice to just be able to write HTML5 markup that's not fully XML compliant. XML content allows it to render really well, or not render really well, but it allows it to be parsed very well by the computer, so the computer can parse a valid XML document faster than an HTML document, which may or may not be a valid XML document. So we'll get into that. Localization, we're going to have support for language files. That's going to tie directly into our views. So when we define static strings, those are all going to be pulled from the localization. We're going to have per system configurations. So we're going to have configuration data for the application, and we're also going to have configuration data for the host. That's going to define things like what database we're connected to, where's our caching layers, where's our Redis service, where's Memcache, where's all of the things that our application is going to depend on. We're going to build a logger, and that logger is going to be extremely fast. I'm going to talk about some ways you can do to speed up your application logging. We're going to avoid hitting the disk until after the page is rendered. I'll show you a couple ways to do that. We're going to do auto documentation. This ties into our inversion of control container because we're defining in our semantics what the program does. That's going to allow us to build some really powerful documentation for our REST API that we're going to build. And lastly, we're going to have input filtering. This all ties in together with the annotation system that we're going to be building and defining what inputs we want. We're going to actually be injecting our inputs. We won't be using get variables, we won't be using post variables, we're not going to be using cookies or any of the super globals. All that stuff's going to be injected into our program class, and it's going to be filtered when our program class runs, so that we know that when we process a post request, all of our inputs are already set on the class and they've already been validated for us. That's something we won't have to do. So let's take a look at what some of the program code's actually going to look like. This is PHP 7.3, so we're going to declare strict types. We have a couple interfaces. This is pretty simple. If you're building a real production application, you may be a little bit more complicated, but the basics are here. We have an interface called view that just allows us to render something. Anything that implements a view can be renderable. So we're going to have two views. We're going to have our actual view layer code, which is our rendering code that takes our template and turns it into actual renderable PHP code. That's going to implement the view layer, and actually our login class can implement the view layer. That way we can return the login class, keep all of our state, and still render it. I'll show you that in just a second. And we have a web page, and a web page can do GET requests and can do POST requests. We could make this a little bit more advanced and do some more RESTful stuff and support some more HTTP verbs here, but right now we're going to keep it simple. We support GET requests and POST requests. Now if you come down here and look at our class, you're going to see something a little interesting. These input annotations. This is going to be used by our inversion of control system to inject all of these variables. Okay, so we have an input here that's a skin. That's going to be our wrapper that defines our header and footer. That skin we're going to set on the skin variable, and we're going to say it's a singleton. We only need one instance of the skin. Please don't new up a new skin every time we have a new class, and that's required. So if for some reason the IOC container can't create this, it's going to error out, okay? And we have an array of input errors that we can access when our class actually loads to tell us if we have any input errors or anything couldn't be instantiated for us. Here's our member variables. Most of these things that are getting injected are public member variables. I did that just for simplicity. The IOC framework we're going to build will support setters. If you want to make these protected or private, you'll be able to do that. And here's what our constructor looks like. There's an important property on this constructor, which is that it does not new anything up. It has no dependencies. Okay, we can new up this class without any dependencies. You can just new it up as long as you've included this login file. This login page is creatable. We have an initialization method. This is where we would do things that we might normally put in our constructor. But as you can see here, our skin, when we create the constructor, the skin hasn't been injected. Okay, so we're going to have to do this after the fact. So we're going to create an init method okay? And that init method defines things like the page title, page description, which login views we're going to be using, all that kind of stuff, okay? Now, what we do is when this login class is going to be newed up by our IOC container. When we call, and we have a get request, we're going to call the get method. We have a post request, we're going to call the post method. In each one of those cases, we need to run our init block here to make sure that we're setting the title on the page, that we've newed up the view, we know exactly which view file we're going to render, all that type of stuff. That's shared. Here's the actual post method. Okay, you can see the get method doesn't take anything. Okay, it just renders the login form, and all it does is return this. Right? We say this implements a view, right? And a view just has a single method called render down here, which I'll get to in a minute. So all we do when we call get is we're going to new up the login class. We're going to call get. That basically returns itself, and then our container, or our web framework, is going to call into this class and just call render. It's going to be really, really simple. And it's going to execute extremely fast. Now, when we have a post, it's a little bit more interesting because we need to define some of our inputs. Okay, so here we're going to use that same annotation. This is that input annotation. We're going to define what type of input this is. So we're going to say this is string data for our username. Okay, what this line is telling our web framework to do is to go find a post variable called username and inject it on the username public member variable right here. Okay, we're saying it's required, and then this is just some simple human documentation. Now what the framework's going to do is if it can't find that post username and it's required, it's going to set that error message on the input error. Okay, if that username variable doesn't match our string filtering which we're going to build, okay, then it's going to set that variable. We may have some type of filters for usernames where maybe we want to say, you know, usernames can only be lowercase alpha, right? And that's it. Doesn't support uppercase characters. We don't want to allow them to type in numbers, nothing like that. We can go ahead and through our filter class, we'll be able to define exactly what we want that to look like in one place. And then whenever we want to use a username, we can say, hey, it has to match this filter. Our web framework is going to read that, and if it's not, and we care about it, we can look at this input error. Okay. Now, I didn't want to get into the database connectivity on this first class because we're going to get into that a little bit later. So here we're just hard coding what a result from the database would be. Here's a user ID 1, has a username Corey, and we're just going to hash the word password. So our actual password is password. We have a method here to format the username, and all that format does is return string to lower. Okay. The reason this is its own function is because we want this to be testable. Okay. By making this its own function, we can create a unit test that says for any given input name, is it formatted correctly? Okay. And that way, once we've written that test, we know that whatever we do to our program, we know that whenever we give it a username, we know that it's being filtered correctly. No matter how we change this program, we know that those usernames are always going to be formatted correctly, all lowercase, alphanumeric, or whatever it is. That's going to be important when we want to look up the user out of the database. We're probably going to want it to be the exact same user regardless of whether they typed it in uppercase or lowercase. And then if we don't have any errors, if the username matches our username, and if our password hashes match, so the password right here from our post variable, this password matches our user data password hash, then we're going to call the success login method. In any other condition, we call the login failure. This is very simple. This code's going to execute, and it's not really making any decisions but these three conditionals right here. And the only thing we're testing for, that there's no input errors, that the username is correct, and that the password verifies correctly. If all those conditions are met, we call login. Otherwise, we call login failure. So let's take a quick look at what those two classes look like, or what those two methods look like on this class. A login failure sets a global success variable to false. That way our unit test can read, did the login work or not, or any other part of the program can know what the status of the login was. We're going to define an error message, set that to be an invalid password. Now if you notice up here, we're using that same error message. Okay, that's the same variable. and we look at the input errors that the IOC container is going to set, and if there's any invalid characters, we're going to present that to the user with this little user string. Later on, we'll go ahead and I'll show you how to internationalize that. Then we take our view. Okay, now you see, and here we're not newing this up anywhere. What we're defining is we have a view, and there should be a new object, and that the inversion of control container, or whoever creates this login class, needs to assign one of those to us. Okay. When we call the initialization method, we're going to tell it, now that we have a view, what view file do we want to use, okay? And that'll be an HTML view that this login page is going to use to render. So here, we're going to define what the error string is, and this error message then will be defined to this variable inside of our view, okay? After assigning the error message to the view, we're going to take our session data, and this is going to end up being a JWT session, and we're going to define a login status, which is false because the user is not logged in. We hit the login failure, and we're going to define a user ID, and we're going to say the user ID is null. Okay. Now, whenever we want to look at what the current session status is, we can either queue off of this login token, or we can look at the user ID value. On success, we're going to do almost the exact opposite. We're going to set the success flag to true. We're going to set the login status to true. We're going to set the user ID to be the value of our user data that we got back. This normally would be a row from the database. And we're going to change the panel to render on our view from the default is the login div. Okay, that's going to be a div file in our view. Instead of rendering that div, we want to render the success div. Okay, and that's going to be a separate div in our view file. So we define this panel, and then we're going to check for a redirect. Okay, so maybe you try to post a comment. The website could say you're not logged in. Please log in. When we go to the login page, we want to after they successfully log in, we want to redirect them back to that comment. This allows us to do that. So we're going to tell our view layer to redirect to our redirect variable if that has been set. Okay, that comes from, if you look again, this post input right here. Now there's an important thing to note here. When we doing redirects, we don't want to have an open redirect in our web framework. We don't want to allow, or in our web page, our login page, we don't want to allow the user to redirect the visitor to evil.com. So we're going to filter the redirect value to a path, okay? And when we define this filter, this is going to limit us to things like some path, okay? And it's going to enforce that this redirect variable matches this path. We're going to have a few different mechanisms for how that filtration works. We may want it to error if it doesn't match, or we may want it to replace characters. So for instance, if we have, let's say we have a filter called alpha, and someone sends in foobar space boobaz, we might want it to replace that to foobar underscore boobaz or foobar star boobaz. And when we build our filter class, we're going to define how that stuff works. And once we've defined the success panel for the success message, once we've looked at whether or not we need to do the redirect and done the redirect, we're going to return this reference to ourselves, which, if you remember, our login class implements view. And we can now, the framework will know that the return class has a render method. It's going to call render, and we're going to render two things. We're going to render a styles div, and we're going to render whatever our defined panel is. So if we call login success, that's going to render success div, and if we call login failure, it's going to render the default, which is the login page. It'll render that login page with any errors that we might have set. And that's it. That's our entire login application. We're excluding the database call. We'll get into that when we do the database stuff. In the next video, I'm going to show you what this inversion of control container looks like that's going to inject all of these variables. And the last thing I have to show you on this is some tests that we've created here. I've created a really tiny test framework for this login class. It has a session mock, which allows us to just set an inspectable key value store for our session data. We have a view test, and the view test allows us to mock out our view object with an inspectable versions of whatever we've set. So whenever we set a view variable, whenever we set metadata, whenever we call render or redirect, all those are going to be public variables that our test can use to inspect to see what the program did. I don't usually like using mocks, but I feel like this is maybe 25 lines of code, so it's not too bad. We're not using PHP Unit. I don't have anything against PHP Unit. I just wanted this to be super trivial and super easy to follow along, and I wanted everything to check in when I commit this to GitHub. So I've created a really trivial test class. We have one to check equivalency for expected and actual values. We have one that checks whether or not this value equates to true. And then we just have some text to print a happy message. And we have red error values and green success messages. And this is the login test class that I defined. This login test class makes sure that we can new up the login class individually. We make sure that the name formatting changes Billy, uppercase Billy, to lowercase Billy. We make sure that the render method renders the login div successfully. We check that the password validates if we pass in a username and the valid password, that we get the success div. And we test that an invalid password, you notice the S here is uppercased, renders the login div, and that we set the error message to invalid username, or that it contains that, right? We're doing a stir in this error message to see if it contains an invalid username. And if these things fail, we're going to get a red error message, and if everything works, we're going to print this happy message. That's it. This is our entire test framework, is these three functions right here. We can create any test class that we want. It's really basic, but the reason I did that is because I wanted to include everything. So that kind of gives you a flavor for what we're going to be building in our web framework. I think the important takeaway points from this class are that it doesn't new anything up. Everything's injected. It defines inside PHP Annotations everything that it needs. That gives us some really powerful functionality, because that's going to allow us to create a test that allows us to inject variables that we can inspect. That allows us to create a web framework that runs in the production environment that we can change whenever we want to. And it also allows us to define via inspection. We can fully document everything that our application does. We can document all the dependencies, all of the inputs, okay, all of the variable inputs into our application or our API, and exactly what the outputs are. And I'll show you when we start building our REST API, exactly how that looks and how we're able to generate the example responses and define exactly what the REST API output looks like right in our Swagger docs that we're going to auto build off of this code. So that's it. I hope you guys like it. If you're interested, hit that subscribe and like button. I'll be doing about a dozen of these for our web framework video. The next one I'm going to put up will be on inversion of control. Thanks, guys. Bye.